I'm going to be talking about multiplying and dividing monomials. A monomial is a number, variable, or product of numbers and variables. For example, 17y minus x times z squared are all monomials. This term z squared is actually an example of an exponent. In general, the expression x to the power n, written like this, means x times 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 x, where x is multiplied by itself n times. In particular, z to the power 2 just means z times z, or 4 to the power 3 is equal to 4 times 4 times 4, which equals 64. In the expression x to the n, x is called the base, and n is called the exponent. To be able to manipulate monomials, we first need to understand how exponents work. Here are a few rules for how to use exponents. If we have the product of two powers with the same base, such as x to the n times x to the m, then we get x times times x, where x is multiplied by itself n times, and then we multiply this by x times times x, where x is multiplied by itself m times. Since there are n copies of x on the left and m copies of x on the right, multiplying these together will give us n plus m copies of x. So this is just equal to x to the power n plus m. Next, let's suppose we have the expression x to the n raised to the power of m. Let's rewrite this using the definition of x to the n. Inside the parentheses, we have x times times x, n times, raised to the power of m. Now, raising to the power of m means we have x times times x, where this is n times, multiplied by x times times x, which is also n times, and you keep doing this m times, like that. Notice now that we have a product of n times n, m copies of x, since the x's here are arranged in a grid with m rows and n columns. So this is equal to x to the n times m. Finally, suppose we have a product raised to a power, like x times y to the power n. Again, using the of raising to the power n, this is x times y times x times y times times x times y. You can put parentheses around these to make it more clear. And this happens n times. Now we can use the commutative property to rearrange this as x times times x, where there's n x's, and then y times times y, where n appears, or y appears n times also. Now it's easy to see that this is just x to the power n times y to the power n. Similar to multiplying powers, we can also divide powers. Suppose we have the expression x to the n divided by x to the m. If we expand this out, we have x times times x, n times, divided by x times times x, m times. Now if n is larger than or equal to m, we can cancel out all the x's in the denominator with x's in the numerator, like this, etc., and we'll be left with x to the power n minus m, since we'll be taking away m x's from the top. But what happens if n and m are equal? If we have x to the n over x to the n, then our formula tells us this is equal to x to the n minus n, but that's just equal to x to the power 0. Since x to the n divided by x to the n is a fraction where both the numerator and denominator are the same, it's equal to 1. Therefore, x to the 0 is equal to 1 for any x. The exception to this rule is if x is equal to 0, since the fraction on the left would not be defined in that case. In fact, 0 to the power 0 is undefined. We can take this formula even one step further. What if n is actually larger than n? If n is smaller than m, then x to the n over x to the m equals 1 over x to the m minus n, since n copies of x will cancel in the numerator and denominator. So now our formula tells us that x to the n minus m equals 1 over x to the m minus n. But notice that on the left side, the exponent is negative. So this formula actually defines for us how to take the negative exponent of a number. If we choose for n to be equal to 0, then this formula reduces to x to the minus m equals 1 over x to the m. So this formula now tells us what it means to take the negative exponent. Finally, we have one more rule for dividing powers, which is that x over y to the power n is equal to x to the n over y to the n, which is done in the same way as multiplying x and y would be done. Now, using these new tools for dealing with powers and our old tools for dealing with multiplication and division, we can manipulate monomials easily.